Hello, welcome back. Day 6. Doing calculus. Today is domain and range. This is a big section, mainly because it's not big like today. It's not big tomorrow. It's big for calculus. You have to understand properties of things like domain and range the farther you want to go. If you don't understand domain and range by their definitions, and furthermore by like their understanding of how they interact with the graph and the equation, like if you don't understand domain and range in every possible context, whether it be from a table of values, a graph, or an equation, it is super hard in order to advance farther, because there's just so much detail you will miss out on if you don't understand those concepts. So today we're going to take a look at all three of those parts. A table, which is the smallest part and the fastest to get through, an equation and a graph, and we're going to discuss, what are the tricks and ways to determine what the domain is, and then what are, some of your problems. The video I sent out last time was pretty good. Both of them were decent. If you ever want to know, like, if I struggle with a topic, I love the organic chemistry tutor. He's boring. Just don't get me wrong there, he's boring. I thought I was boring, he's boring. But man, like, he is willing to just sit down in there and make like a 2-hour video over anything. And that can be helpful because he goes through a lot of examples, talking through his process a lot. And if you want to just sit down and look at what he's doing and look at his work, it's top quality. So please, if you need extra help with domain and range, those videos I posted last time are still good. I'd highly recommend them, even if they are a bit on the dry side. Just take a look at them. We have a pretty short homework assignment tonight, but there's a lot of detail to it. So let's make sure and take a look at our problems today. So for today, let's look at those 3 basic properties. So when we talk about domain and range, let's remind ourselves, when it comes to domain, this is the list of acceptable, inputs or independent variables. This is what you can plug in if you're talking about an equation. This is your x-axis if you're talking about a graph. Okay, that's your domain. Versus the range. The range is kind of the opposite. Instead of being a list of your acceptable inputs, it's a list of acceptable outputs. Or it's a list of your dependent variable. Or if you want to talk about your equations, your domain has to do with your x's and your range has to do with your y's. Now, we've kind of gotten ingrained in high school that x is the x-axis and y is the y-axis, but this could easily be any other variable. As long as it's the one you're plugging into, it's your x. As long as it's the thing you're getting out, it's your y. Alternatively, so we talked about function notation last time, this can also be your f of x. So now let's look at the 3 big categories. The first category is by table. A table usually consists of a listing of values, 2 columns, but there's a secondary way to show it here. I'll do it in a second. Let's go with like a couple of really basic ones. So, if I talk about this table, I can list the domain and range relatively easily. The range is just a list of all possible inputs. So in this case, the domain would be 0, 1, 2, 3, and 4. It's a listing, in curly brackets, of every possible input. The range is a listing of every possible output. Now you can put it in any order you want, but it's common when you're looking at things like domain and range to put them in non-repeating order. So for example, the lowest number would be a 1, the next lowest would be a 2, the next one would be a 3, and even though 3 is duplicated, I don't need to write it a second time. And the highest number would be a 7. And so this would be an example of the domain and range of a table of values. You take all the inputs, list them in the domain, you take all the outputs, list them in the range, and ignoring duplicates. And so it's possible for these two to be different sets, different types of values. It's possible for there to be 5 in this one and 4 in this one, as we have in this example. It's possible for there to be infinitely many in the domain, but not the same amount in the range. And so it really matters a lot. Alternatively, Sometimes you won't see it listed in a table. Sometimes you'll see it in a list. But it's the same basic thing. Lists are usually pairs of points, and in fact, I'll make this the exact same list. So it'd be like the point 07, the point 13, the point 21, the point 32, and the point 43. Like, this is the exact same information, but one's in a table, one's in a list. And because of that, these would also have the same domain and range. Again, the domain lists the acceptable input values, or the first value in each ordered pair, and the range indicates the possible output values, or the second values, in order with no duplicates. So, this is by far the easiest one, and there's none of these in your homework. It's just good to remember that this exists. But let's look at the second and third type. These types are the ones that are going to make trouble for us, because this is where we actually start to get into some real math. So, second type we need to talk about is the equation type. Now, in the equation type, it's important to note that anytime you talk about an equation, that you have to understand, like, what the independent variable is, what the dependent variable is, where are the x's, where are the y's, the functions, in order to answer questions like this. Because if you can't answer those questions, then you can't really understand, like, how to fit things like domain and range. So, let's take a look at an example. Excuse me. In this case, I'm going to use the equation for my first example. 7x minus 4. Now, when trying to determine domain and range with an equation, there are two major things to look out for. First major thing to look out for is any variables in the denominator. Any variables that happen to be in the bottom of a fraction. That's the first big thing to look out for. Second big thing, I'm going to leave some space here because I know I'm going to put some more information up there, is any radicals. Specifically, I want to look for what I call even radicals, because that's going to matter a lot. If these two aren't in your problem, it's good to assume that your domain, put the third one on here even though we won't talk about it until tomorrow. It's the third one called piecewise. But if it doesn't fit into one of these two categories today, we're probably not going to do anything. So you'll notice in this example that I do not have anything in a denominator. No variables in a denominator. Notice it's variable specific. It's got to be the variable in the denominator. I have no fractions, so I have no denominators. And while I could make this into fractions over like 1 and stuff, there's no denominators. There's also no radicals, which means that in this case, it is safe to assume, since it is not piecewise either, which again we'll talk about next time, the domain in this case is supposed to be all real numbers. Or if we do it in interval notation, from negative infinity to positive infinity is an acceptable value. Let's redefine what this means. In words, this means that any x can be plugged in and a y can be found. In other words, if I pick any x, anything between negative infinity and positive infinity, I can plug it in and get an answer. If I pick negative 20, I can plug it in and get an answer. If I pick negative 10, I can plug it in and get an answer. If I pick negative 2, I can plug it in and get an answer. If I pick 5, plug it in and get an answer. Pick 17 over 4, like I can plug it in, I can get an answer. It works. The big times you do not get an answer are anytime you end up dividing by 0. That's a problem. If there's ever a time when you could possibly divide by 0, that is an issue. That is going to cause problems in our domain. And secondary, if there's any time we end up with a negative inside a radical, that can cause a problem. Because if you remember from your algebra, a negative inside the radical means you end up with imaginaries, and calculus is done in the real numbers, at least for the first 2 classes you take. You can do calculus in imaginary numbers just like anything else, but you don't want to do that yet. It's not fun. So these are the two situations that can cause a problem. Either we end up with a 0 in the denominator, but that's not possible because there's nothing in the denominator, so we can ignore this first one. Or if there's a negative inside of a radical, which again we can ignore because there's no radical. So in this example, there's nothing divided by 0, there's nothing in a radical, so we say that all real numbers work. Now, when it comes to the range, you can apply the exact same process. So this would be like your domain list. For range, you can do the same thing. But you have to do it with the inverse equation. Now, in this example, what is the inverse equation? Well, remember that for a function, the inverse equation is defined as, so if my original equation is y equals 7x minus 4, the inverse equation is if instead of solving for x, we solved, or instead of solving for y, we solve for x. So we could do stuff like, add 4 to both sides, and then we end up with y plus 4 equals 7x, and then we could divide both sides by 7, and then end up with x equals y plus 4 over 7, or y over 7 plus 4 over 7. Once you've got the inverse equation, you can actually ask these two questions again. Is there any possibility of dividing by 0? Well, if you look here, y is on top, 7 is on bottom, 7 can never be 0. That's a basic property of mathematics. 4 on top, 7 on bottom, 7 cannot be 0. So this top one, again, nothing happens with it. On the bottom one, you can clearly see that there's no radicals. And so for this example, we would also say that there is all real numbers for our range, or if we want to do it in interval notation, negative infinity to positive infinity. Now, just to kind of showcase how this works with a graph real quick, because graph's the third type, there's no graphing ones in your homework, but that doesn't mean it's not useful to know. Take a look here. So, if I was to take this function, and with that function, I was able to type in the equation 7x minus 4. If I look at this graph, I might want to zoom out a little bit. Give it a second. So the zoom is standard, which is number 6. If I graph this thing, let's see if it hits something else. Zoom 6. Okay, there it goes. All right, if I graph this thing, you can clearly see that this graph will continue going down and to the left and rising up and to the right, and will continue doing that forever and ever. Which means that if you look at the x-axis, there's no gaps, there's no holes. Like if I choose this number over here and I follow my hand down, I will eventually touch the line. It may be way down here, but I will get there. If I go to the right and try a number like this one, if I go up, I will also eventually touch the line. So like you can always do an eye check and say, hey, if I put my finger on the axis and then go either up or down, do I eventually touch the line? And if the answer is yes, then it's in the domain. So -1 is in the domain because if I follow down, I will eventually touch the graph. -4 is in the domain because if I follow down, it will eventually touch the graph. 3 is in the domain because if I follow up, it will eventually touch the graph. So I know every number that I've talked about is in the domain. There appears to be no breaks, there's no gaps. So this appears to be a good function. Notice in the y, the same thing happens. If I go to the y-axis and go to like y is 2, there's y is 2. If I go to the left or right, I have to see if I eventually touch the line. And in fact, I do. I touch it right there. So 2 is in the range. If I go up to 6, and I go left or right, yes, 6 is in the range because eventually I do touch the graph. If I go up to 9, 9 is in the range because eventually I do touch the graph right there. Down here at -5, I do eventually touch the graph right there. Down here at -8, I do eventually touch the graph over here. So there's no gaps in the graph anywhere. And that's what the range is looking for. It's asking, hey, on the x-axis, is there any gaps in the graph? On the y-axis, is there any gaps in the graph? Let's compare this to our next problem. For our next problem, let's look at a different equation. So my equation in this case is going to be the equation, let's see, 5 minus x squared. So I'm going to put it in function notation. F of x is equal to 5 minus x squared. Well, if we look at this original equation, let's talk about the domain. Let's perform our two tests. Is there ever a time I divide by 0? No. There's nothing under 5 except a 1. There's nothing under x squared except a 1. Neither of those are zeros. So the domain appears to be from negative infinity to positive infinity, or all real numbers. But what about the range? To look at the range, I need to find the alternative equation, what we call the inverse. Well, my original equation is f of x, which I'm going to call y, because remember they're the same thing. Y equals 5 minus x squared. Take a watch. I'm going to solve for x. Now to solve for x, I'm going to do it in a couple different ways. I'm going to move the x squared and the y. I'm going to interchange those using some algebra. This is a pretty common algebraic step that you can do. So basically, I added the x squared and subtracted the y all in one step. I can then take a square root. And when I take a square root, I end up with x equals plus or minus the square root of 5 minus y. Now you notice here that this equation, which is related to the original equation, this equation has y solve, but it's got a radical. This equation has a problem, because there's a chance that if I pick certain y values, I will get a negative answer. For example, if I pick the number y equals 1. If I pick the number y equals 1, then I end up with 5 minus 1, which is 4. That's acceptable. But if I pick y equals 6, 5 minus 6 is negative 1. And you can't do a negative radical without staying real. Like, you have to go to imaginaries. And so this one fails. So there's a nifty little thing you can do to find the range. What we do is we take what's inside the radical, which is 5 minus y, and we set it equal to 0. This will help us find what's referred to as the boundary point. The place where this function stops working. So what I can do now is I can add y to both sides and end up with this. 5 equals y. So I know in the range somewhere, I either have to I'm going to start at 5 and go to infinity, or I'm going to start in the negatives and end at 5. Like, these are the only possibilities. Now, quick question. Does 5 work? And so I have to ask, if I plug in 5, does it work? Yes, 5 works, because 5 minus 5 is 0, and you can take the square root of 0. So it's either this one or that one. It's got to be one of these two, with a parenthesis on the infinities. So notice how I find this number is by solving it for x instead of solving it for y, and then I have to look and see when will this thing equal 0. So 5 minus y, that inner piece, when is equal 0. If there had been a number outside, we would ignore it. It's not important. It's only if it's inside that it counts, just like Aladdin, okay? So these are the two possibilities. Well, which one is it? Well, we knew that 1 works. Well, this one doesn't contain 1. This one contains 5 and anything bigger than 5. 1 is not bigger than 5. This one's out. But this one contains 1. And this is, in fact, the range. And I can prove that by looking at the graph. Let's take a look. We're going to take this equation here, and we're going to plug that into our graphing calculator. So here we go. Let's verify that we got the right answer. So 5 minus x squared. Now, those of you that are very good at this, you will find that quite often you can just use the graph to find the domain and range. But if you are incapable of, weird. If you can't type it in and get a solution, then you don't have the ability to graph this. So take a look. If I look at the x-axis, every point on the x-axis will eventually touch the graph if I go up or down. So for example, if I start at 0, Like if I go up or down from 0, yeah, I'll touch the graph up here. If I go to 1, yes, it's in there, because if I go up or down from 1, I touch the graph right there. If I go to 5 over here, if I go up or down from 5, I have to go down, and I have to go down pretty far, but I will eventually touch the graph. Same over here with like 9. If I go over to 9, yes, eventually the graph will meet up somewhere like down here somewhere, okay? If I was to extend this graph down, yes, it would eventually get there. Same with the negatives, right? And so that's why in my original function, we end up with the domain being all real numbers, because every x gets a solution. But look at the second part. Look here. Look why this is the case and how we can show that in the graph. So here's my graph. Notice that if I use my y values now, let's go to y is 1. Well, y is 1 has two answers, one here and one there. So we know it works. Y is 3 has two answers, one here and one there. Like if I move left or right from 3, it works. If I go to 5, I have to zoom in a little bit, but yes, it does in fact go to 5. But what about 6? Right up here. If I go left or right on 6, it will never ever touch that graph. That is because at 6, the graph keeps going downwards. It never gets up to 6. Nor 7, nor 8, nor 9, nor 10. So everything above 5 is out. Which is why when we look at the list, our answer is everything 5 and below. Remember, what this statement means is everything below and including 5. And because it's talking about the range specifically, this means that the y values are everything below and including 5. Now, this process can be a pain, like finding this equation. That is why most algebra teachers will tell you, hey, just graph the sucker, okay? Just graph the thing, get it in this form, and we'll make it work, okay? If we can graph this, we can see, yes, the y values are in fact 5 or less. But if for some reason you're struggling with that, if you can't figure out what the domain is supposed to be, the other process does work, where you just find the inverse and get the solution that way. It requires a bit more work, and you have to know it, but it works. Let's do one more. We've seen one now where there ends up being a radical involved. Notice we didn't start with a radical, it ended with a radical. And so that can change my solutions. I have to keep that in mind. So let's take a look. Another problem. Note again, the two cases where I can end up having problems is if I end up dividing by 0 at any point in time, or if I end up with a radical of the negative inside of it. Those are the big ones. Let's look at one that has a fraction now. In fact, let's look at one that has both. Ooh, that's going to be fun. Let's do that last. Okay, so let's do another example, one with a fraction now. So in this case, I'm going to have f of x is equal to 3 over x minus 4. Okay, let's talk domain and range. So, domain. To determine the domain, what we need to do, we need to check to see, is there ever a case where those two things happen? You know, this is a test. Is there ever a time when I end up with a negative inside a radical? Or is there ever a time where I end up dividing by 0? And it turns out there is. If you look at this function, what happens if x equals 4? Well, if x equals 4, then I end up with 3, so that'd be f of 4 from using our function notation. It'd be 3 divided by 4 minus 4, and 4 minus 4 is 0, so we end up with 3 over 0. This is a problem. This can't happen, which means that x cannot equal 4. This is a restriction on the domain. Because we end up dividing by 0, x cannot be 4. But notice that if I chose 5, it works. 3 over 5 minus 4 is a number. It ends up being 3. If I chose 20, it works. 3 over 20 minus 4 is a number. Yeah, it's not a nice number, but it's a number. And so we get an answer. But 4 is a problem. Now, One of the easy ways you can find these answers is, again, you just take the piece that's troublesome, which is that x minus 4, and set it equal to 0. Notice that in both cases we've talked about, right? We took the troublesome spot, right? The square root of 5 minus y. We set that piece equal to 0. The over x minus 4, we take the x minus 4 and it's equal to 0. Notice the 3 isn't doing anything, right? Notice the radical isn't doing anything. It's what's inside of it that matters. The x minus 4 on bottom is where the problems can lie. That's how we know that if we solve this equation, by of course adding 4 on both sides, that x equals 4 is the issue. That's how I know that this is going to work. X equals 4 is the problem. And that's how I got this answer up here as well, is I take the nasty piece, so the 5 minus y, which is inside the radical, and set equals 0. I apologize for the train. Okay. So this tells me my domain should be everything except x is not equal to 4. Now, how do we write that? Well, we can write all real numbers. X cannot equal 4. That's one way to write the answer. Or we could write everything below 4 combined with everything above 4. Those two answers are both acceptable. I'm going to go to my graph real quick. Pull this thing up. There it is. I go to graph. Clear this out. And let's type this in. So 3 divided by, I'm going to put that in parentheses to make sure I get it right, x minus 4. If we're right, then at 4 something weird should happen. Aha! So take a look. What happened at 4? Well, if I go over here to like -7, or -8, or -9, like if I go up or down from -7, -8, or -9, I do eventually hit the graph. If I go up or down from -1, if I go down, I do hit the graph. If I go at 2, I can go down and hit the graph. If I go at 3, I can go down and hit the graph. What happens at 4? If I go down, notice that we're never really touching the graph. We're getting close. But there appears to be a gap in your graph where we're no longer getting an answer. But if I jump over here to 5, like there's an answer, it's up there. Go over here to 6, there's an answer, it's right there. Go here to 7, like no matter what x value if I pick, if I go up or down from the x value, 3 works. 4 doesn't. 4 ends up being what's called an asymptote. And so you can see in this example, this is why my domain ends up being all numbers except 4. Or from -infinity to 4, and from 4 to infinity. Now let's talk range. Now, I can either use the inverse like I did before, or I could instead use the graph. The better you are with graphs, the more you can rely upon them. I'm totally okay with that. Use your skills to your advantage. But, on the other hand, when you look at this function, I'm going to use the other method. Y equals 3 over x minus 4. So I'm going to take this and I'm going to solve it for y, or solve it for x instead. So to do that, I'm going to cross multiply. So I end up with y times x minus 4 equals 3. I'm then going to divide by y on both sides. So I end up with x minus 4 equals 3 over y. I'm then going to add 4 to both sides. End up with x equals 3 over y plus 4. Notice again, Notice again you have a fraction. Fractions are places where there could be problems. So I'm going to check that fraction. I'm going to check it and see what happens here. I end up with y equals 0. Remember, I take the bottom part of the fraction and I set it equal to 0. The only thing on the bottom is the y. So what's this mean? It means that the y can't be 0. Because if y is 0, look at the function. What do we get? We get 3 divided by 0 plus 4. We cannot take 3 divided by 0. That's not allowed. Dividing by 0 is a problem. So if y is 0, we end up with an issue. Which means that for the range should be all real numbers except y can't equal 0. That's one possibility. Or, of course, you could write it in the other notation. From -infinity to 0, and from 0 to infinity. Notice that if I plug in y as 1, I can get an answer. 3 over 1 plus 4 is a number. If I plug in 10, 3 over 10 plus 4 is a number. 3 over 50, figure 50 plus 4 is a number. If I plug in any other number besides 0, this works. But at 0, there's a problem. And so when I look at my range, 0 is an issue. Now look at that graph one more time as we finish up. It is in this graph. If I pick y as 4, so 1, 2, 3, 4. If I pick y as 4 and I move left or right, eventually I do touch the graph. Right there. Boom. I got an answer. I pick y as 2, go left or right. Boom. There's an answer. If I go to -6, go left or right. Boom. There's an answer. If I go up to -1, there's an answer. If I go up to a half, there's an answer. But at 0, if I move left, I never touch the blue line. If I move right, I never touch the blue line. It never touches it. It gets close, but never actually gets there. And if you zoom out some, you'll see that that's true. Now, you might ask me, Douglas, be honest. Which method do you want me to use? And I'm going to look you in the face and say, I don't care. If you want to use my technique, which is an advanced technique, in order to get your range correctly, do it. It's not always easy. And for some problems, it's downright near impossible. You have the option tonight in your homework. I ask you in your homework problems, find domain and range. That's all the instructions are going to say. Now, how you find it is entirely on you. If you use the graph, I want you to include the graph in your homework. So if you decide to grab a graphing calculator and graph it, I want you to copy those graphs down so I know what you were looking at. Because then I can see if you make a mistake. If you choose to use the equation, then I want you to show your work. Okay? Depending on which way you do it, just find the domain and range. I don't matter which way, as long as you do it one of the ways. That's going to end up being it for me. I'll talk to you guys tomorrow about graphing some more. How to graph equations by hand, which is pretty fun. But otherwise, that's it. I will see you guys tomorrow. Tomorrow will be Thursday. It'll be our last day of the week. We'll have our Zoom session then. And I'll see you guys then.